Hi, my name is Craig Stiers. Thank you for joining the session. Today we're going to talk about how organizations are using modern data architectures on AWS to achieve specific outcomes for their businesses. You may already be aware that AWS has over 80 services, but for today, as we look closely at modern data architectures, we'll really focus on a few of the relevant ones. We'll talk about storage, the role of security, identity, compliance, and of course, analytics and artificial intelligence. First, let's look at designing modern data architectures to deliver at scale. We'll look at this from the view of the different business outcomes that you may be trying to achieve. Now, the first outcome that businesses are going for is often around modernization and consolidation. These investments are typically made to enhance existing business applications, or sometimes even to create new digital services. The objective is often to better enable people who are making decisions, providing them with better, faster information that gives them insights about the business that they just couldn't access before. We can think of this as trying to stop FOMO, or the fear of missing out. With these initiatives, organizations look to also become more agile and well-run. Now, a customer of ours, Aon Benfield, is the world's leading reinsurance intermediary and full-service capital advisor. In the week leading up to the Brexit vote, Aon Benfield offered a service to their customers which allowed them to run simulations as to what would happen with their current portfolios if the Brexit vote went for or against. The image that you see here is the actual campaign they pushed through Twitter. And what they were offering was quite unique. Using AWS, they were able to scale up the amount of high-performance compute capacity to run a huge number of simulations. Moving at this speed and scale just simply wasn't possible with their traditional on-premise systems. So these modernization and consolidation projects commonly fit into one of a few categories. First are the insights projects. These tend to be named something like 360 view of customer or a 360 view of the business. These connect to and link together data from a number of different back-end systems. This information is made available on demand or integrated into the existing user's applications. The second category is around digitization. Legacy applications that may be hard to access today are made available through web services. Automation is built in, and insights are made available on demand. The third category is data monetization. This is a way for businesses to create new revenue streams by enriching, aggregating, and selling information collected about their business. The diagram that you see here is a Lambda architecture. It's a way to represent how data flows through a system, being processed in different ways and served to users. We tend to see a good approach to designing an architecture like this is to start with the users of the system. The users for a modernize and consolidate project tend to be a data analyst or a business user, or even external buyers. We can then work backwards to figure out which data sources are needed to fulfill their requirements. Often these data sources are transactional data, data out of the ERP systems, and data that comes from their digital properties, like their web logs and cookies. This data gets ingested into the system through standard internet protocols, like HTTP and FTP and SSH. But there are also a number of other facilities to connect a customer's data and applications, including using AWS Direct Connect, which is a private connection that runs between a customer's data center and an AWS data center. There's other services like S3 transfer acceleration, storage gateways, and database migration services. Now, let's talk about one of the benefits of using the cloud. It's around decoupling storage and compute resources. Legacy design systems were tightly coupled software and hardware built into a single large system. If an organization was running out of capacity, they would have to buy expensive upgrades like additional racks and nodes. This model does not scale well and is often painful for the business. Big data architectures have a very different profile from a traditional data warehouse, and they benefit a lot from decoupling the storage and compute. Huge volumes of data may be stored, but only some of it's processed at a particular time. It's helpful to have storage that scales up without having to pay for the unused compute. Now, on the other hand, for organizations that are running very compute-intensive workloads, they may want elasticity in their compute resources. which is one of the major benefits of using AWS. A core component of any modern data architecture on AWS is the Amazon Simple Storage Service, or S3. When we talk about decoupling storage and compute, well, this is the storage. This is a highly available object store that has 11 nines of durability. It's a feature-rich storage service that includes versioning, granular access controls, and the ability to trigger actions on events. Our other services are designed to take advantage of these S3 features. Let's look at the Amazon Elastic MapReduce, or EMR service. This is our fully managed Hadoop offering. With just a few clicks, you have a production-ready Hadoop cluster up and running with Spark or Presto or any of the other applications that are built in and ready to use. It's optimized to use S3, giving customers the ability to decouple the Hadoop compute and storage resources. This allows for some pretty interesting use cases that just weren't possible with traditional Hadoop clusters. Now you can run a very large Hadoop cluster for just a few hours, process data, and turn that cluster off when you're not using it, only paying for the inexpensive S3 storage costs when the cluster is off. You can also take advantage of the AWS spot market, which is your ability to bid on our unused capacity and pay a fraction of the price for compute. What we see from our customers is a move away from running a single multi-purpose Hadoop cluster that is meant to fulfill all the business's requirements. Because of the flexibility offered with click-to-start, fully managed Hadoop as a service, customers now run purpose-built clusters. A common case is doing large-scale ETL. These are jobs that typically need to finish within a batch window. For instance, end-of-the-day data processing that must finish before, say, 5 a.m. This is a great use case for leveraging Spot in the underlying EMR file system, or EMRFS, using S3 as storage. Another use case is for analytic modeling and interactive query. A popular application for this is Apache Spark and Spark Streams. For data scientists and data analysts, this is their ability to run as if they're on top of a massive compute grid. And when they're not using the cluster, they can turn it off and not pay for those unused resources. Another use case is for processing streams of and semi-structured data. These clusters tend to be smaller and run 24 hours a day, 7 days a week. These process chunks of stream data, like clickstream, connected devices, and any other stream of data flowing into the cloud. These take advantage of event-based architectures. So when data has been processed and is ready, the next stage of the pipeline can be triggered. A third core service is Amazon Redshift. This is our fully managed data warehouse offering. It's a massively parallel processing, fully relational data warehouse that uses industry standard SQL with added functionality. It's optimized to run analytic queries very quickly at scale. You can start small with a cluster in the gigabytes and scale all the way up to petabytes because this service was designed to take advantage of the scale of the cloud. It will cost you less than 1/10 of what you would pay for a traditional data warehouse. Now, going back to the Lambda architecture, we look at the process for bringing data into the raw data storage pre-processed. It then goes through a data processing stage of ETL and data quality. Customers often use EMR to do this using either Hive for running migrated SQL jobs or sometimes running Spark. After the data has been cleansed and tagged, it's then placed into a staged data area, often called a data lake, which is an organized set of S3 containers. Throughout the entire lifecycle of data, secure access and governance are very important. There are a few key services that will help you with this process. The first is AWS Identity and Access Management, or IAM. This is a role and user-based service that offers granular control over all the objects and services within AWS. The next is Amazon Key Management Service, or KMS, which allows companies to use and control their own encryption keys. Then there's AWS CloudTrail, which is a service that logs and monitors every access request that's made to services. Finally, Amazon CloudWatch offers performance monitoring to help customers maintain a high level of service for their applications. Now that we have the data made available through the data lake, it can be served into the applications which will be accessed by users. Let's first look at loading the data warehouse for dashboards, query, BI, and other reporting. Many organizations will have applications that are running on legacy databases like SQL Server or Oracle. These may feed from the data lake to enrich and enhance existing business applications. Different personas use different interfaces to access the underlying services. Data analysts will often use a BI tool for data visualization and exploration, like Amazon QuickSight. Or external buyers that are accessing underlying data services would do so through the Amazon API Gateway. Now, let's look at the second outcome, which is innovating for new revenues. In this context, innovation is often driven by unique new insights available through advanced analytics. It's how businesses are finding the known unknowns. These organizations start operating differently based on what they now know about their customers and start to reach out to them in new and personalized ways. This applies to product launches, campaigns, supply chain management, packaged services, and even customized offerings. Let's look at how these predictive models are built within an AWS modern data architecture. Another of our customers, Robinhood, provides zero commission trading to individual investors. Traditionally, in this market, organizations would offer equity trading to individuals at a fixed fee per trade. Now, Robinhood took the institutional investor rate of $0 per trade and handed that back to its customers. Instead, Robinhood runs a wide range of analytic services on its platform and offers those insights back to its customers. This value-add service is what customers are actually paying for. What makes Robinhood even more interesting is that they built a business handling over $1 billion in equity trades and saved their customers $22 million in trade commissions. And they did all of this with just 2 DevOps resources because of the high level of scale and automation that AWS provides. These innovation for new revenues projects often center around a few different categories. The first are personalization projects. These often are behavioral segmentation and micro-segmentation sorts of initiatives. Second is around demand prediction. This gives businesses the ability to look into the future and best understand possible scenarios. The third is around measuring risk, and by understanding exposure of different scenarios, being able to take the best course of action. We start this next architecture discussion from where we previously left off. The pipelining of data through raw staging, through processing stages into a data lake, and into a serving layer. We now want to look at how we can capture real-time data. This is where we look to Amazon Kinesis, our fully managed real-time streaming service. Kinesis offers auto-scaling for streams of data and can handle up to millions of events per second. The storage is also replicated across multiple facilities, offering extremely high durability of this data. Real-time data often arrives in a semi-structured or unstructured form. We've released a service, Amazon Athena, which allows interactive query directly against data stored in Amazon S3 using standard SQL. This is a schema-on-read service. It does not require movement of data or clusters to configure. It's a pay-per-query service and often complements the other highly structured query services. Look back at the data sources that we're now taking in. In addition to those we looked at earlier, we now see connected devices, a core part of IoT, and social media data. Looking on the bottom of the ingest layer, we now see Amazon Kinesis. This service captures these sources of real-time data and streams them into the raw data stage. That data is then moved into the S3 data lake and is accessed directly by Amazon Athena. And if it's more text-based, then through Amazon Elasticsearch, our fully managed Elasticsearch offering. These services tend to be more commonly used by the data analyst. Now, let's dig a little bit deeper into how predictive models and other advanced analytics are created within this platform. There are a few services that can build predictive models. One is Amazon Machine Learning, or AML. This fully managed model building service greatly increases the speed of creating, testing, and using models. Because it's a black box service, it also lowers the skill barrier to allow individuals with less programming experience to work with more advanced analytics. We often see this used for recommendation engines, for logistics services, and finding patterns in connected devices. The next and more advanced models will be built on Amazon EMR running Spark, and maybe also using the MLlab libraries. These more advanced analytics include behavioral profiling and creating industry-specific models. When we talked earlier around the different use cases of Hadoop, this is the case where R and SAS and Python programmers are going to be using the massive grid processing capabilities of Hadoop. Now, for edge cases and very advanced analytics, you may use the deep learning services. Amazon is investing a lot in MXNet, as it's open source and we feel the innovation in this community has potential to really grow. Now, to keep this diagram a bit cleaner, I'm going to condense down these services into just one icon, which from now on we'll just call Advanced Analytics. The scored data sets that are the outputs of these models are pushed into the data lake and made available to the highly structured data query layer and into existing applications. These might be targeted campaign recommendations, guidance for inventory management, or demand forecasting that gets integrated into operational systems. What you now see is a common build pattern for analyzing data at scale and automating actions based off insights. You see that a number of different user personas are served with this architecture: the data scientists, the data analysts, the business users, and the engagement platforms for providing highly personalized interactions to customers. Now, we've talked about modern data architectures at scale, so now let's talk about architectures for speed, specifically for real-time analytics and engagement. For this third outcome, what businesses are trying to achieve is around real-time engagement, capturing a window of opportunity. This could be the minutes a customer is browsing an online store, the seconds that someone is using voice command, or the milliseconds that a person's eye is passing by digital signage. Every business benefits from providing superior customer service. As companies are looking to create strong advantage over their peers in the market, some of them are looking to do it by providing better real-time engagement with their customers. Increasingly, they're looking to the vast streams of data being produced that measure location, capture video feeds, behaviors, environmental conditions, and more. For you gamers out there, you're probably familiar with Clash of Clans. This blockbuster game by Supercell has some great examples of high-level engagement of its users. Supercell, a good customer of AWS, has built a modern data architecture that can detect gamer behaviors and moods, including excitement, frustration, and boredom. But in order for these insights to be meaningful, they need to be able to respond to gamers within seconds and sometimes even milliseconds. Let's look deeper into which kinds of architectures support these kind of real-time analytics. The third outcome of real-time engagement often centers around a few categories. The first is interactive customer experience. We really hear this discussion focusing on creating natural experiences for customers and using interfaces like mobile and voice to create more native feeling experiences. The second is around event-driven automation. Business automation is a big focus for more and more organizations, and this is where cost savings can be dramatic, creating big lift in profitability for companies. The third is around fraud detection, as businesses continue to do more to protect their customers and to protect the interests of the larger business. Now, as we look at how events are captured in the speed layer, we'll see that there's another event capture kinesis stream that's receiving data off the ingest layer. And if you remember, we talked about there being a third configuration often used for Hadoop, which is the processing stream data. Well, here it is. The analyzed stream is processed in chunks through an EMR cluster, often running Spark and using the Scala libraries. These results are pushed across into the batch layer into the raw data buckets. From here, it's used to build analytic models to look for patterns, to build segmentations and predictive models. An important part of an event-driven architecture is the use of serverless compute. We have a service called Amazon Lambda, which offers the ability to run application code without having a server to manage. Lambda can be triggered by events that come off a kinesis stream, or if there's a change that's been made to an S3 bucket. As we are capturing events, we may want to enrich the contents of these events. To do this, let's talk a little bit around the newly released AWS AI services. Amazon Recognition is an image recognition and analysis tool which allows searching, verification, and organization of millions of images. For instance, within this picture, recognition has detected a villa, a garden, a swimming pool, and many other items. The facial recognition capabilities of recognition are able to give relative scores for emotion and facial expression, as well as other attributes like gender and if the person is wearing sunglasses or not, has facial hair, and so on. Looking back to the speed layer at the bottom, we see that event data is often forked. On one path, data is captured for analytics and modeling. On the second path, the event is processed to capture and respond within that window of opportunity. The change to the kinesis stream triggers the event handler, which is a Lambda function. Amazon AI may be used to further enrich the request by understanding what's in an image or processing voice data. The enriched event is then sent to an event scoring engine, which determines the next course of action. This event scoring engine may have predictive models that have been published from the advanced analytics modeling above, then coded into a language like Python. Or, if the event scoring engine is accessing a black box service, whether that's AML or a third-party provider, it makes a call out with the parameters, then takes the results and makes a determination for the next course of action. Another Lambda function is then called, which is the response handler. In cases with low latency requirements, the response handler updates DynamoDB, our fully managed NoSQL offering, which is then polled by the engagement platform or is used in the next stage of automated response. This diagram now shows how a number of different outcomes are served by a single modern data architecture. As you continue to improve your business and create better engagement with your customers, analytics and effective use of data will be critical. We've looked at the design patterns for modernization and consolidation projects, or dealing with the fear of missing out, for innovating for new revenue, finding the known unknowns, and for real-time engagement, capturing those windows of opportunity. The final category is around building for global scale, using complete automation and industry best practices. This is covered in our deeper dive workshops on modern data architecture. That brings us to the close of this session. If you're like so many of our customers which are leveling up in this area, I hope this session was useful for you. If after today you're wanting to ramp up your AWS capabilities, there are several options available to you. To gain more confidence and hands-on experience with AWS, watch our instructional videos and explore the self-paced labs. You can also attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. And finally, remember to validate your technical expertise with AWS certifications. Do remember to provide feedback on today's event so that we can improve the event experience for you in the future. With that, I'd like to thank you for attending AWS Innovate.